Now let's divide a more complicated radical. So whenever we have the square root of 160 x to the 6th y11 over the square root of 10x y to the 4th, we can actually rewrite that as all underneath the same radical and then begin canceling it. So we have 160x 6y11 over 10x y to the 4th. The only way we can combine these all underneath one is as long as the root up here is the exact same. As long as both of these are square roots, we can continue to do it. So now with it underneath all one radical, we can begin canceling. So 10 takes out a 10 from the 160, leaving a 16. Because 160 is 16 times a 10. Oops. Now, this x on the bottom can take out one of these x's from the top. So we are left with a x to the 5th, and this one's gone. Now we have 4 x's or 4 y's on the bottom and 11 y's on top. So these 4 y's can remove 4 from this y, and we have y to the 7th. So now, once we are simplified, we actually have nothing left in the bottom, right, other than a 1. There's always a 1 there. But we have the square root of 16 y to the 5th, or x to the 5th, and y to the 7th. So now let's simplify. 16 is actually a 4 times a 4. We have 5 x's, 3, 4, 5, and we have 7 y's. 1, 2, 3, 4, 5, 6, 7. Because it is a square root, right? It's like there's a little 2 up here, right? Because it's a square root. Now we're looking for 2 in a group. So we have 2 4's. Here are 2 x's. Here another 2 x's. Here's 2 y's. Here's 2 y's, and here's another 2 y's. For each of these groups, it comes out as a single item, so I'm going to bring that all the way over here. And we are left with a 4. We have 2 x's, so that is now an x squared. We have 3 y's that are coming out, so that is now a y cubed. And remaining underneath the radical are those single digits or single items that we have, which are a single x and a single y. So then it is xy. So our radical, or our dividing radicals, now equals 4x squared y cubed times the square root of xy. Let's try one more. So now we are going to simplify the square root of 175 x to the 11th y squared over the square root of 7x y squared. I'm not even going to write it underneath one radical because you don't have to. You can go ahead and continue to do the cancel from here. 175 is 7 times a 25. So that lets this 7 cancel that 7. Okay. I now have 1 x on the bottom. I have 11 x's on top. So this 1 is going to take one of these, and we now have an x to the 10th power. Now I have a y squared on the bottom and a y squared on top. So this y squared completely takes out this y squared. If I'm rewriting now, what I'm left with underneath the radical is the 25 that's left, and x to the 10th. So now we can break it up and simplify this radical. So 25 is the same thing as a 5 times a 5. We have 10 x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Remember, every pair, because it is a square root, we're looking for pairs. So every pair comes out as a single. So I have a pair of 5s, a pair of x's, pair of x's, pair of x's, pair of x's, pair of x's. So this now simplifies, bringing it over here to, there is a 5 on the outside. We have 1, 2, 3, 4, 5 x's, so x to the 5th, and there are no individual items left, so we don't have a remaining square root at all. So your final answer is just 5x to the 5th.